Hello students and viewers, welcome to Physics Magic. Today I will discuss the chapter vector, which is very important for class 11, 12, for the board exam as well as for the entrance exam. From today's discussion, the things we will learn: number 1, concept of vectors; number 2, types of vectors; number 3, parallel shift of the vectors; number 4, angle between the vectors; number 5, basic fundamental of vector addition. Dear students, please take this class as a real class. Please take a notebook and write down the topics and play the video multiple times to understand the topics. Now let's come to the point. What is vector? What is vector? What is vector? Vector is a quantity which have both magnitude and direction. Vector is a quantity which have both magnitude and direction. What is vector? Vector is a quantity which have both magnitude and direction. Now let's explain this quantity with an example. Before explaining vector, we have to understand what is a scalar. And now come to the example. Just let's a man is moving 100-meter distance. Then we can say the only distance is a scalar quantity because it have only magnitude, no direction. But if you can say that a man is moving towards east a 100-meter distance, then that quantity we can say the displacement. The displacement is a vector quantity. So distance 100 meter, it is a scalar, and the 100-meter distance covered due east, it is a, that is displacement, it is a vector quantity. Why? Why is it is a vector quantity? Because displacement have the magnitude 100 meter, that is the distance, and it has east direction. So the vector quantity is that quantity which have both magnitude and direction. The magnitude here is 100 meter and direction is east direction. Now let's explain this quantity, vector quantity, with another example. Let's a man is moving with a car having a velocity 40 km per hour due north. This velocity is a vector quantity, but what we call that 40 km per hour is the speed of that car. So this speed is a scalar quantity, and when we say that the man is moving with a car with a velocity 40 km per hour due north, along the north direction, then we can say the velocity is a vector quantity. So just cleaning. Velocity 40 km per hour due north, it is a vector quantity, and 40 km per hour only, this is the speed and this is a scalar quantity. So every vector quantity is associated with a scalar, and the extra point that vector quantity have the direction. Now we discuss the different types of vectors. Types of vector. 1. Unit vector. Unit vector is a vector whose magnitude is 1 and whose direction indicates the direction of a vector quantity. So unit vector is a vector whose magnitude is 1 and whose direction indicates the direction of a vector quantity. For example, suppose A is a vector. A is a vector. The unit vector associated with the vector A is given by A cap. A cap is the notation of the unit vector. A cap unit vector notation such that A cap mod, that is value, that is magnitude of unit vector, is 1. And unit vector is, just cleaning, write down this unit vector. Unit vector is represented as A is equal to vector A by its magnitude. That is, the unit vector is represented by the ratio of a vector quantity A and its magnitude, such that A cap is equal to 1. So if a vector quantity is A, then A is equal to mod of A into A cap. If you multiply the magnitude, that is a scalar quantity of that vector, with the unit vector, then we can get the vector quantity. Now take a three-dimensional Cartesian coordinate system. OX, OY and OZ. This is a three-dimensional Cartesian coordinate system. The unit vector along the x direction, it is taken as I cap. The unit vector in the y direction is taken as j cap, and unit vector along the z direction is taken as k cap, such that I cap mod is equal to j cap mod is equal to k cap mod is equal to 1. It does not mean that every unit vector is equal. Every unit vector has the magnitude 1, but every unit vector has the different direction. Now we come to another type of vector, that is equal vector. Now what is equal vector? Equal vector. Equal vector are the vectors whose magnitude and direction both are same. Equal vectors are the vectors whose magnitude and direction both are the same. Now, let's explain with an example. Just AB is a vector, A is the tail and B is the head, and CD is another vector. CD is another vector. C is the tail and D is the head, such that AB is equal to A vector and CD is equal to B vector, such that both have the same magnitude. Mod A is equal to mod B, that both AB vector and CD vector both have the same magnitude, that is modulus of A is equal to modulus of B, and both AB and CD, that is both A and B, have the same direction. Same direction means the angle between the two vectors is 0 degree. Then we can say that both AB and CD are equal vectors. Then we can say both vector A and vector B are equal vectors. Equal vectors. We can represent the equal vectors like with the following example. A is equal to B. Now we discuss the another type of vectors, equal and opposite vectors. Equal and opposite vector. Equal and opposite vectors. What is equal and opposite vectors? The vectors which have equal magnitude and the direction is opposite to each other, then the vectors are equal and opposite vectors. So what is equal and opposite vectors? The vectors which have equal magnitude and the direction is opposite to each other, then the vectors are equal and opposite vectors. Just take an examples. AB is a vector A and CD is another vector C, D, another vector D. AB have the direction in this direction and the vector B, that is CD vector, have this direction. We can see from the diagram that both have the opposite direction, and these vectors you can say equal and opposite vectors when both have the, that is mod A is equal to mod B, that is both have the equal in magnitude but direction is opposite direction. Magnitude means length is equal, both have this length is equal, mod A is equal to mod B, then AB, that is vector A, and vector B is equal and opposite vectors. How can we represent the equal and opposite vectors? Just A is equal to minus B. Minus indicates the opposite direction. Minus indicates the opposite direction. Now let's take another type of vector, that is coplanar vector. Coplanar vector. planar vector. The vectors which lie on the same plane in a 3D space are called coplanar vectors. Let us take a three-dimensional Cartesian coordinate system OX, OY and OZ. Let us take two vectors AB and CD. This AB and CD, two vectors are coplanar because they lie on the xz plane. AB and CD lie on xz plane. So, AB and CD are coplanar vectors. Similarly, we can take another two vector EF and BK, BG lie on the YZ plane, then EF and BG are also coplanar vectors. Collinear vector. The vectors which lie along the same line or the vectors which are parallel, they are called collinear vectors. Collinear vector, the vectors which lie along the same line, that is act along the same line, or the vectors which are parallel, they are called collinear vectors. The angle between the collinear vectors is 0 degree. Just draw the diagram of the collinear vector. That is AB. A is the tail, B is the head. Take another vector line acting along the same line, BC. This vector is A and this vector is B. This A and B are collinear. And I take another example, DE vector and GH vector, that is D vector and F vector are parallel, they have the angle 0 degree, they are also D vector and A vector are also collinear. D vector and F vector are also collinear. The angle between the collinear vectors is 0 degree, they are acting along the same line or they are parallel, that is angle between the collinear vectors is 0 degree. Position vector. What is position vector? Position vector. The vector using another ink. the vector which indicates the position of a point with respect to a reference point in a space. In a space is known as position vector. Take a diagram. Let draw the three-dimensional Cartesian coordinate system OX, OY and OZ. Let it take a point P in the xz plane, then join the P XYZ. This OP is the position vector. OP is the position vector of point P with respect to the reference point O in three-dimensional space. Later we can discuss in detail the position vector. Now just know that is position vector. If we say that is OP is equal to R is equal to xi cap plus yj cap plus zk cap. X, y, z is the coordinates of the point P and ijk is the unit vector along x direction I cap, j cap is the unit vector along the y direction and k cap is the unit vector along the z direction. After discussing the types of the vectors, now we will discuss a very important topic, parallel shift of vectors. Shift of vectors. AB is a vector A. We can shift this vector parallelly to the position CD. This is also a vector A. What is the parallel shift of the vectors? Parallel shift of the vectors. Parallel shift of the vectors is the shifting of vectors without changing the magnitude of the vectors and the direction of the vectors. So what is the parallel shift? The parallel shift of the vectors is the shifting of the vectors without changing the magnitude and without changing the magnitude and direction. That is AB and CD, both A. That is both have the same magnitude. So we are shifting this vector AB to the position CD without changing the direction because AB and CD are both parallel and both have the same magnitude. Now take another example.
DE is shifting to position GH, both are taking B, that is DE have the same magnitude GH, DE having the same magnitude GH, and DE and GH are parallel, that is without changing the direction. This is the parallel shifting of vectors. Now we can discuss very important topics, that is the angle between the two vectors. Angle between two vectors. Angle between two vectors is the smaller angle between two vectors when they are joined head to head or tail to tail. What is the angle between two vectors? Angle between two vectors is the smaller angle between the vectors when they are joined head to head or tail to tail. Now take the diagram. Write down first of all. Take the diagram. Let take A vector and V vector. They are joined, that is AB and AC. They are joined tail to tail, that is at the point A. So the angle between the two vectors is 90 degree. Let us take another example. The vector A and vector B, this angle is 120 degree. Now this is AB and this is BC. AB vector A and BC vector B, they meet at the point B. A is the tail of a vector AB and B is the head. The tail of the vector BC is B and head of the vector is C. So these A vector and B vector are joined at head and tail, head to tail. So this 120 degree we can't take as the angle between the vectors because these are the not head to head or tail to tail point. So what is the process in such case? So just shifting the vector parallelly, shifting the vector AB parallelly, that is along the same line without changing the magnitude and direction. Now the vector is in this point. So this vector AB now meet at the tail to tail. So what is this angle? This total angle is 180. So 180 minus 120. 180 minus 120 is equal to 60 degree. So this angle is 60 degree. So now we can say the angle between the vectors A and B is 60 degree, not 120 degree. You can say the vector, again take another vector A and B, and this is C. So two vectors, suppose A and D, the angle here is 30 degree. They meet at the head to head. So you can say the angle is 30 degree. Why? Because here there are two angles. The angle between the vectors they meeting at the point B is 30 degree. This is also the angle. That is total angle is 360 degree. 360 degree. So this angle is, the external angle is 360 minus 30. 330 also. So when they are meeting at the head to head, you can say that is the angle between the vector is 30 degree. Why not 330 degree? 330 degree is also the angle at the head to head, because the angle between the vectors cannot be greater than 180 degree. So theta is the angle between the two vectors, theta greater than 0 and less than 180 degree. We are explaining the angle between the two vectors with another examples. This vector is taken as A, this is O, this is B, this is C, and this is D, and this is E. This is 30 degree, this is 60 degree. So we have to find the angle between E and C here. E and C here. Find out the angle between E and C. How can you find out the angle between E and C? Just take the point O. This is the head of the vector E, head of the vector E, and this is the tail of the vector C. This is the tail of the vector C. So this head of the vector E is joined at the tail of the vector C. So this is the angle 90 degree, because 60 and 390. So this is the angle 90 degree. So this angle, you can't say this is the angle between 90 and 60, 150 degree. You can't say, because they are joined at, this vector have the head and this vector have the tail, joined head and tail. So you can say, that is when you have to find out the angle between the two vectors, you have to join the vectors at head to head or tail to tail. So just shifting parallelly this vector E to this position. Now vector E is here. So now you can say the angle between E and C is this angle here. This angle. So what is this angle? Because this angle is 30 degree. This is opposite angle. This vector E, this angle, and this is the angle is opposite vector. This is the 30 degree. So angle between the vector E and C is not, that is 90 plus 60, not 150. This is the wrong answer. This is the wrong answer, because this is not the angle. Because why the head and tail of another vector is joined here. So to find out the angle between the two vectors, you have to join the vectors at head to head or tail to tail. By parallel shifting this vector, this position, now the vector E is here. So now the angle between vector E and C is 30 degree. Why 30 degree? Because this is 30 degree and this opposite angle is 30 degree, just opposite angle. So now the angle between two vectors E and C is 30 degree. So this is the right answer using parallel shift. Now we discuss the basic fundamental of addition of two vectors. That is head and tail method. Head and tail method. Now just cleaning. Head and tail method of vector addition. A is a vector and B is another vector. How can we add this vector? That is, take A, B and this vector take this C, D. How can you add this vector with the head and tail method? The head of the vector, head, and this is tail, and this is the vector B has the tail and this is head. Just shifting the vector AB parallelly in this place without changing the magnitude and direction. This is now AB and CD is the vector shifting parallelly this position. This is C and this is D. That is the vector AB. This is the vector B. This is the tail of the vector A and this is the head of the vector A. And this is the tail of the vector B and this is the head of the vector B. So now the head of one vector, first vector, is joined to the tail of another vector, second vector B. So what is the addition result of the two vectors? That is known as resultant. The resultant is the joining line of the tail of first vector and head of the second vector. So resultant, the result of the addition of two vectors is known as resultant. Resultant AD, that is known as R is equal to A plus B. You can say by the head and tail method, head tail method. But you can't find out the value in this case because the angle between the two vectors is not fixed here. So take another example. The vector AB in east direction, this is east direction, and vector CD along the north direction, this is tail, this is head, and this is tail of vector B, and this is head of vector B. So join the head and tail of the vector A and B joined here. So the tail of the first vector and join the tail of the first vector and head of the second vector. This is the resultant AD, that is R. Here if you say the value of A is 4 and value of B is 3, magnitude of, that is magnitude of A is 4 and magnitude of B is 3, then by the Pythagoras theorem, so the value of R is equal to root over 4 square plus 3 square, that is the value of the resultant is, you can determine 5 by the head and tail method. Why? Because this angle is 90 degree. You can apply the Pythagoras theorem here, but in the previous case you can't determine the angle between the vectors. So you have to apply the different laws, that is parallelogram laws, triangular laws, to add the vectors. How can you find out the resultant? By using head and tail method. Just join the tail of the first vector and head of the last vector. So in the east direction 4 and 4, so total displacement is equal to 4 plus 4 is equal to 8 meter along east direction and total displacement is equal to 3 plus 3 is equal to 6 along south direction. So how can you find out the resultant? This is the take 4 plus 4 8 along each direction total, and this is the along south direction total 6. So this is tail of first vector and this is head and this is tail of this vector of having 6 value. So join the, so this is head, sorry. So join the tail of this vector to the head of this vector. Applying Pythagoras theorem, we can find out the resultant. R is equal to root over 6 square, root over 8 square plus 6 square. So 64 plus 36 is 100 is equal to 10. So resultant value R is equal to 10 here by applying head and tail method.
If this video is useful to you, please like, share and subscribe my channel to get the uninterrupted educational benefit. Please mail to us for queries and other information. Our mail address is sonjipal12@gmail.com. Thanks to all. Jai Hind.